Welcome to Summarize Science, where we break down the latest research for you. Have you ever wondered what the weather is like on a planet hundreds of light years away? Thanks to a technique called eclipse mapping, astronomers are starting to create actual 2D maps of the atmospheres of these distant worlds. The James Webb Space Telescope has been a champion at this, giving us our first incredible glimpses of alien climates. But JWST is like a superstar celebrity. It's incredibly powerful, but its time is extremely limited and in high demand. It can map a few planets in stunning detail, but it can't conduct the massive survey needed to understand the big picture of how exoplanet atmospheres work as a whole. This is where a new mission comes in, the Ariel Space Telescope, set to launch in 2029. This paper asks a critical question: can Ariel, a smaller and more specialized telescope, pick up where JWST leaves off and conduct a population-level mapping survey? To find out, the researchers ran a fascinating simulation. They took the ultra-high-quality maps already made by JWST and digitally observed them with a simulated Ariel telescope. The goal was to see if Ariel could successfully reconstruct the original map from this new, less detailed data. For the brightest and best targets, the results are fantastic. The study found that Ariel can create maps that are qualitatively similar to JWST's using the exact same amount of observation time. For dimmer, mid-tier targets, Ariel needs to stare a little longer, about 3 times as long in fact, but it still gets the job done, accurately mapping the planet's thermal structure. But what about even lower-ranking planets, where stacking dozens of eclipse observations would be impractical? This is where the team found a clever and much more efficient solution, observing the planet's entire orbit, not just the eclipse. This phase curve method captures the changing light from the planet's full day side as it rotates. This technique provides so much extra information that it allows Ariel to create a high-quality map of a dimmer planet with just a single, full-orbit observation. The study also revealed Ariel's specific strengths and weaknesses. It will be an expert at mapping features along the planet's longitude, or east to west. This is crucial for measuring things like the day-night temperature difference and how far the hottest point is shifted by powerful winds. However, it will struggle to see features along the latitude, or north to south, as those signals are much fainter. That job is best left for JWST's powerful mirror. So, what does this all mean? The researchers used these findings to propose a groundbreaking survey for Ariel. They've identified 87 prime targets for a population-level mapping study. This survey would map planets ranging from warm Jupiters to ultra-hot Jupiters, covering a huge range of temperatures, sizes, and gravities. And incredibly, this entire survey could be completed in just 1/4 of Ariel's primary mission lifetime. So, to recap, this research confirms that the upcoming Ariel telescope will be a powerful eclipse mapping machine. While JWST acts as a high-detail zoom lens for a few special targets, Ariel will be the wide-angle camera, capturing the essential climate data for a massive population of planets. By observing full planetary orbits, it will efficiently map their east-west atmospheric dynamics. The proposed survey of 87 worlds would be the largest of its kind, creating the first-ever large-scale catalog of alien weather maps. This will allow scientists to move from studying individual, unique planets to understanding the fundamental rules that govern the climates of worlds across our galaxy.